Okay, so I think the recording has started. Okay, so this course had its genesis from some of the recent research that I have been doing in the area of bias and fairness, and through my interactions with colleagues all over the world. um, During these interactions in my conference visits, I felt that this kind of a course was in the lacking, at least in India. And so I planned this course and proposed, thankfully it also got a course sponsorship from Google. And hopefully we will also see some speakers in this course from different industries who are actively working in this area. Okay, so as you see, there is a question with which we are starting, and this is the question that we would try to kind of answer all through the course. So our intelligent machines, or like quote unquote what you say AI, are they our friend or are they our foe? So this course is all about the quest of the answer, quest for the answer to this question. Okay, so this will be primarily taught by myself, and from time and again there will be invited speakers either from the academia or from the industry, talking on special topics. But this would be starting from somewhere in March. By that time, hopefully we will have a good grip of the subject so that you can absorb the invited lectures. So this course will be assisted by three PhD students, Punnojoy Shaha. So Punnojoy, if you are here, maybe you can switch on your video and say hi to the students.
Yeah.
Okay.
Hi
Then
everyone.
Shayantan. So Punujoy works especially in hate speech detection and mitigation. So which is something that we will also have a detailed set of lectures on, which we call the content governance part of the AI ethics course. Then we have Shayantan, who is working on historical text processing. And maybe Shantanu, you can say hello to the students. And then we have Siddharth, who is working on bias and fairness in user interface systems. So Siddharth, if you are here, if you could switch on the video and say hi to the students.
Yeah, hi everyone.
Okay, so and the contact that you see there is your primary point of contact for all the course related questions. So this group reaches myself and all the TAs. So one more thing is that we will build a Google group of all the students, because that way communication is easy and faster. Through the ERP, it sometimes slows down, and you get the message much later than wanted. So we will have a Google group soon once the student list has more or less frozen. Okay, so the course will have regular lectures, and then there will be continuous evaluation. I have already told you about this in the email that I had sent you yesterday. So I hope all of you have received the email. That's why you are joining you are able to join the link. So there will be like three short tests of 1 hour duration, like spanning over the whole semester. The tentative dates also I have shared with you. And then, like, what is more important is that we will have a term project of 40 marks. So this is like a project. It's a like full-fledged research project that you will be doing in a group, and you will we will try to give you some hands-on exposure to the kind of problems that typically experts solve in this area, because as you can understand, this is a strongly research driven course. We will try to uh, associate each group to a mentor who will be the primary point of contact for that particular term project, and then the mentor will give you necessary materials, data sets, etc., whatever is needed. And there will be two presentations, one like, so the term mid-sem and end-sem are vague in this online semesters, but somewhere close to the middle of the semester, we will have one presentation and one at the end of the semester. So of course, like this is an experimental course, but we have been doing this core experiment for the last 2 years, and now, like with the experience of the last 2 years, we have learned some of the things, I should say, a little better. And again, we will not have any regular attendance. Students come by their own choice, driven by the interest in the course. And in case you are missing some course lectures, you might also land up missing some guest lectures. So some of these guest lectures are interesting because you get to interact with people directly working on these problems from the industry uh, and academia, and which might like enable your higher studies or job prospects. Okay, so again, as I said, that this is an experimental course, so we do not have any regular textbook so far, but hopefully by the end of this year, there will be a book coming up, especially on this topic. But till then, like we will be following some of the hand notes from different uh, like. Similar courses that are taught elsewhere in the world, as well as like multiple papers that we will like get introduced to in the course of the lectures. Okay, so I understand that all of you are well versed with the basic idea of artificial intelligence, and this audience does not need an introduction to the definition, but for the sake of completeness, it's kind of like, the ultimate goal is to have a machine which can mimic the cognitive capabilities of like humans, those which you see in humans, like where, so one of the cognitive capabilities, for instance, language, the other cognitive capability is vision, and then the third is like the mental understanding, or which we call the processing of the mental lexicon. So all these important cognitive abilities that you typically tend to see in humans, the desire is to see the same in machines, which are driven by some sort of algorithms at the back end. So, and like again, this slide does not need an introduction. You see AI everywhere, every day. It is affecting our lives uh, uh, like faster than even we can, perceive. And most of this AI algorithms these days are data driven, and the decisions that these models make uh, are actually either directly or indirectly affecting many of our day-to-day life decisions. And therefore, it is important and very imperative to know more about about the workings of these mathematical models, their virtues, their vices, and this is what this course is going to tell you about, like how to formally uh, attack these mathematical models, like quote unquote attack these mathematical models, so that you understand whether the workings of this model are in favor of are favorable to you, or they are not. So, the question is, so we start with a very simple question, and then like we will see like how things get more and more complex. So, why the rush to AI? So, I guess all of you would agree that currently computing has become very cheap, and there is like huge availability of data, like the whole web is at your disposal, and we are able to develop better and better algorithms with the help of this, of course, with the help of this cheaper hardware. So which was not possible even like 10, 15 years back. So, and therefore the number of articles that deal with one of these keywords like machine learning, artificial intelligence, pattern recognitions. This is not scientific article per se. It's like all articles on the web. If you see like how they are growing, so it is obvious that from the plot on the right hand side that it's like kind of exponential. And I think like it's beyond saying that if you look for the next 6 years from 2015 to 2021, like these graphs have been much further superseded by an even more exponential, in fact I would imagine a super exponential behavior. So uh, and decision automation has become kind of inevitable, because we are all the time dealing with very large systems, and in these large systems, think of a very big factory, like there are different objectives that are part of the production plan of the factory, and many of these production objectives cannot be met without um, uh, devices which are in turn controlled by some sort of hardware software programming paradigm. So and many of these are also data driven in the sense that they learn from their past behavior. So another important thing is, as I have mentioned in the last point, so many of these industries need to work 24/7, and it is impossible for it is impossible only with human effort to achieve this. So therefore you need autonomous decision making systems, like where you have miniature robots, machines with robots built into them, so that you can keep the entire pipeline of the industry awake all through the day and night. So now the issue here is that these decisions actually are guided by previous decisions, and not only the decisions but also the outcome of those decisions. And by the outcome, like you can think of some sort of a positive outcome where the machine took say a decision to do something, or a negative outcome where the machine took a decision to not do something or refrain from doing something, assumption but without any loss of generality. Now, the point here is that if you think a little bit more carefully, that unless you teach the system uh, some sort of a value, like the kind of values, that social values or moral values that are ingrained into humans, like by their upbringing, by their environment, by their like surroundings, by their family. So this kind of exposure is not there um, in the machine world, and therefore there are certain issues that can very easily crop up in this kind of an automatic decision making process. And that is one of the things that is going to concern us in the next few lectures, as you will see. So mm, also, like we are now trying to develop algorithms which would be able to encode our intent. And by this I mean that even before like telling something, just through the touch of some of the devices, the machine will know what you are trying to probably say you're trying to order, you're wanting to order a pizza, and that's there in your intent, but you have not even articulated. The machine tries to make a map of the thought process in your brain, and from there the machine tries to make a like perception sketch, and automatically asks you whether you are wanting to go for a pizza or not. So this kind of a dream system is like what like people are working on a lot in this in the context of what you say, quote unquote, modern AI. So yeah, so basically, as I was telling you in the last to last slide, that you are trying to teach intent to software. Now, this, as I said, could have its inadvertent consequences. And this is very nicely shown in the right-hand side figure. You say that you see that there are two people handshaking, but each of them have the vices hidden at the back of themselves. So now what happens is that in many cases, it has been observed, and this is some of the things that these are some of the things that we are going to read in much more details, is that software or an algorithm could be, led in a way so that, or taught in a way so that it only like does or has positive intent for the friend of the algorithm designer, and has negative intent for the enemies of the algorithm designer. Now, like when I say the algorithm designer, it actually includes in itself a very large number of entities or role players. So this could be, think of an e-commerce platform which tries to design its algorithm in such a way so that some of the products or some of the sellers are actually shown to the users much more, to the customers much more frequently, or in more advantageous positions compared to the other users, compared to the other sellers or other products. So these kind of things, like as we will see in the course of the lecture, happen quite frequently. And this is one example where an algorithm has been taught to make decisions in favor of certain entities, whereas to make decisions against certain other entities. So while like you are promoting in some sense certain entities whom you consider to be your friend, you are demoting some others. And this friendship could have a lot of motives also, like it might not be like a simple friendship, but it could be motivated further by money, etc. Okay, So now, like the good part of AI is like kind of appreciable by all of us. Like it has allowed us to be highly precise. Like these kind of data-driven algorithms have allowed like many of the systems, many of the uh, like real-world working systems to be very, very precise, much more reliable, like as you see in the right hand side, the aeroplane driving. So I myself have witnessed airplanes, like long flights where the pilots sleep and it's only the computer that drives the plane unless there is some turbulence. So, and this is a first hand experience. So increased savings, of course, like you have less human in the loop, and therefore like you do things like you save money that way, and you do things faster. That's also a way to save money. And there are various other like things, you do it much more precisely, so that also like implicates some sort of like additional revenue and things like that. So there is overall a lot of increase in the savings. Of course, better safety because you have much finer control on, say, devices that you use during like starting from warfare to agriculture. More speed, as I have already said, that this kind of AI algorithms, like with lost a lot of optimization on the hardware side and a lot of like distillation on the software side, like we are gaining enormous speed in decision making. So in fact, there have been like this kind of wishful thinkings, like although this is a dated newsprint, but even if you look at the current some of the current newsprints, you will see some similar observations where like people try to foresee whether intelligent agents or like decision making algorithms could predict wars much before they would happen, and could also you know suggest ways to mitigate this kind of wars, like much before they could have taken place. So I guess like all of you are aware of the IBM Watson system. So this is like this was one of the dream goals of IBM, to build something, as I said, as cognitively similar to a human being as possible. So, and they had like numerous utilities under this Watson program, starting from dialogue to text to speech to vision to speech to text to language translation to like concept formulation to visual recognition, and like so it's like the number of applications are kind of huge. And like if you are interested, it's a good read about how Watson came into popularity, what is the current status now. So as far as I understand, that the current interest has to some extent subdued, but I think there are still a significant number of people working in this toolkit, or working on this Watson like project, and IBM is spending like quite a few, I mean, a significant fraction of its revenue on the development of this project. Okay, so one of the most like impactful like journeys of AI is in healthcare, and it's a huge market now in the healthcare, and there more and more like you have this automatic devices or which are called affective devices, which are being developed and which are which are tasked to understand your brain signals and accordingly function. So there is a lot of money that is being poured in with into this domain, and a lot of AI algorithms which try to bridge the gap in some sense is are being built. So and in fact, there have been a lot of futuristic, hopeful comments that have been made by well-known personalities. By the way, anyone knows about this person, Ray Kurzweil? Anyone in the audience? Who is he? None? Okay, so he's an American inventor, and he has a lot of contributions in text-to-speech systems, dialogue systems, and uh, he has, I think he has given uh, hugely many popular talks on like how AI is going to change the uh, face of human life. And like there are extreme strong hopes that are being expressed by the school of people who follow the ideology of Ray. However, with all good things, there are, as you understand, bad things. So the question is is there anything that is worrisome? So is there anything that should bother us? And it turns out that at least while there are people like Ray who are very positive about AI, there are others equally successful people who have been quite skeptic and apprehensive about the developments of AI. And as you see, like here, Hawking's points out to this last excerpt where he says that humans limited by slow biological evolution couldn't compete and would be superseded by AI. So this is a very burning concept that has come up of late, and and a new terminology has been coined around it. And anyone knows what is this terminology? This idea of superseding humans?
Singularity.
Yes, a little more specificity in the terminology. You are very close. You are very close. What does singularity imply? Finally,
Like a single event when it will exceed human capacity, sort of.
yeah. So and that is called super intelligence. Okay, that is what
A
is termed
generalized.
as. Yeah, that is what is termed as superintelligence. So this idea of superintelligence is that, or singularity, as he was pointing out, is that um, so there will be a point in time. So researchers have started believing, at least a group of researchers have started believing that there will be a point in time where we will have an intelligent agent which will start recursively learning, and it will learn from what it has learned, and it will again learn from what it has learned, and so on and so forth, until and unless there will be something called an explosion of intelligence. And at this point, where there will be an explosion of intelligence, it is thought that that this intelligent agent will actually supersede the intelligence of humans, and will reach the point of superintelligence. So this is a wishful idea. So, and in fact, there are, it's not only Stephens, there are other like experts who are equally skeptic about this kind of huge development in the AI literature. So, and I think like this is one of the most famous quotes of Elon Musk, where he says that AI is our greatest existential threat. So now the point is like when really smart people get worried, so we probably should pay more attention. So that's why like that's also one of the motivations of this particular course. So if so many people, so many well-known people are getting worried about this problem, then there is something to be really worried about it. Uh, okay, so and there has been a petition. I think it was somewhere in 2017 or something. I don't remember exactly, where thousands of researchers all across the world have sent a petition to the United Nations so that the use of autonomous weapons in any sort of warfare should be banned. So, and from that point, like there has been multiple councils of the United Nations in order to deliberate on this point. And if you are interested, you can go up and look into the current developments. Okay, and in fact, people have started like having themed workshops like safety and control for artificial intelligence, like with this increasing or explosive increase in like decision making in a data driven fashion, like we should be very much concerned about the safety and control of such systems, especially like if they're being used in warfare, in driving, and in other such what you call safety critical systems. Yeah. So, and the point is like it is changing so fast that like it's beyond our realization. So even before we realize, things have changed. So so I'll give you one example. I'm not sure why if all of you are aware of this. So most of the scientific articles that are written on topics related to machine learning and AI are submitted on a open platform called archive, arxiv.org. So this is a nice resource that the Cornell University has built for a long time now, and you can get like the latest developments in this area by looking into or browsing into some of the like scientific articles from this website. Now, the point that I was trying to make here is that if you go to this website and if you start reading a paper, say some paper on vision or some paper on NLP, you will see that like in within 15 days, I mean, so that would be the average time. Within 7 to 15 days, you will see that there will be another paper on archive which is working on the same idea and has beaten the previous idea in terms of performance. So this is the kind of growth. So it's like so every like so if so one of my senior friends in IIT Bombay, he kinds of make this joke very nicely that like if on Friday you have some benchmark performance and you are trying to read up something to think about algorithms to beat that benchmark. On Monday, you see that the benchmark has already been beaten, and you have to rethink and like probably again start from scratch. So such is the development. And of course, like as I was telling you, like this is the uh, probably the ugly part, like where people have been going mad in designing autonomous vehicles, and there have been like huge money that is being poured by different industries, starting from hardware industries to software industries, like trying to develop autonomous vehicles. And these are some of the fatal accident examples that I'm showing you here, which were very, very unfortunate, but like could not be avoided. So it turns out that probably um, the the idea of such autonomous agents like getting deployed in certain spheres of life is still in its infancy, and we really need to think and talk more with not only AI expert but also like people working on road or on the people dealing with hard reality before we think ourselves fully prepared to test our decision making algorithms in real life. So these are the very well-known three laws of Asimov. So these are interesting in their own rights. And when this whole branch of robotics was getting developed, these were some of the things that people were usually guided by while developing intelligent robots. So the first principle of the robot was that it should not injure a human by its inaction or allow a human being to come to harm. Okay. The second one is that robot should obey orders given by the humans as long as the first law is not violated. So, and the third point says that a third law says that robot should also try to protect its own existence as long as such protection does not violate the first and the second law. So these are the three well-known laws of Asimov, which are the guiding principles of development of any intelligent agent so far. Now the question is like, what happens? So the whole paradigm of the development of these laws is that intelligent agents will never come to harm, or the decision-making algorithm is always going to reap benefits. There is no harm that an intelligent agent could actually generate. But then, what happens if there is a situation where harm is inevitable? Like if I give you a situation where there is harm and only harm, there is no benefit that could be obtained from the intelligent agent, then how are you going to distribute that harm? So that is the question. And Asimov's laws are actually clueless about how to distribute harm. So any example that you can think of about such harms? Any example where such harm is inevitable?
So, like an example of a self-driving car where a human is driving a car and a baby comes in front of the car. So the driving car could steer itself into a danger to save the baby, or it could go over the baby to save the human inside the car.
Absolutely. Okay. So I guess you are aware of the moral machine idea. Yeah. So basically, so this is a moral question. So if there is a autonomous vehicle which is running on the road, and there is a baby that comes in in front of it, then whether it should, um, like clutch its gear and put a brake and cause harm to the passengers sitting in the car, or should it run over the baby? So, and it's not only like the question of a baby, it could be just a jaywalker. Okay, so this is a philosophical question or an ethical question, which like cannot be answered using the Asimov's laws as the guidelines. So this is what we call, like in the AI ethics literature, this is what we call the moral dilemma. Yeah, so this is another interesting example of a moral dilemma. I guess some of you are aware of this. This is also known as the trolley predicament. So what happens here is that, so I'll point out the situation, and some of you might tell me, like, what do you think should be the ideal like action? So you see, let me get my laser pointer. Okay, you see that there is a man standing here with a lever. Okay, and there is a locomotive coming on this track. Now, on one track, there are 5 people, okay, who are chatting, and on the other track, there is a person who is actually trying to cross the track to with his or her cycle. Now, this person here has the question that whether the locomotive will be allowed to, like, go straight on the straight track, or he should pull the lever so that the locomotive gets deflected and takes the other track. Okay, takes the which we call the by track, takes the by track. So if the locomotive takes the straight track, then it is going to kill 5 people. Okay, because by the time the locomotive is here, these people, it's too late for these people to jump aside. Okay, on the other hand, like if it is deflected, if the lever is pulled and if it is deflected, then the locomotive will move in the by track and it is going to kill this person on the cycle. Okay, now the question is that what should this person do? Should this person pull the lever or not? So you can send out your opinion on the chat box, and Shanton or Siddharth, one of you can count the opinions.
Okay, sir.
So let us say the train or the locomotive goes on the straight track, let's call it option A, and it goes on the deflected track, let's call it option B. And you can just write A or B. So let's wait for 1 minute and see, like, what is the vote of the class. It's 12:49. I'll take the vote at 12:50.
Sir, I think the chat is disabled.
Oh, is it?
Sir, since you have joined via link, then it mostly is for everyone.
Oh, is it? Okay, that's a pity. And it's impossible to like invite all of you. Let me see if I can do something about that. Okay, so reactions is allowed. Seems.
Sir, maybe we could have a raise of hands for a particular
Yeah,
option.
you can have a raise of hand for option B. No one for option B. So everybody goes for option A.
Sir, could you show the slide again? Which one was option B?
So option B is to deflect. Option B is to deflect. Option A is to go straight. So, okay, there are quite a few. So 8 of you are telling that it should deflect. Okay. Option B is to deflect. I'm seeing 9, 11, 12, 13, 14. Okay. Okay. Fine. So 15 of 27. So can any one of you volunteer and say, like, why do you think option B is what you have chosen? Okay, I have my votes. So I also chose option B, that is to deflect.
Sir, like in a scenario where none of the options are going to bring any benefit, like everyone is losing, so we would like to minimize the number of lives, right?
Very
So
good. So yeah, that
in
is
that scenario,
usually our moral principle, where like typically we would try to minimize the casualties. So, and that's why like option B is preferred over option A. Now, quickly, let me give you another scenario. So, okay. So think about it back at home after the class. So I'll give you the other scenario. So here, now imagine that there is a very fat man standing here, and you are here. This liver person is not here. You are here, and you have the opportunity to push this fat man on this track. And you can assume that if you push this fat man on this track, then this locomotive will be stopped, and all these people, this cycle person as well as these 5 people, all of them will be saved. Will you be willing to push that fat man? So this is a guiltless person, has no evils associated with him, but he's just standing there benign, and you have the opportunity to push that fat man down so that, like, he falls on the track, and the locomotive comes and like hits the person and stops there. So would you be willing to do that? So that's the second question, to ponder over it. Let's not vote now. Okay. The other one is like an example, is a hands-on example in which I was involved. So this is a recent research that we published. So I guess many of you are aware of facial recognition systems, where, given a face, the software is able to identify the gender as well as sometimes the age from the picture. Okay, and we tried to test 3 standard commercial facial recognition system, one that comes from Amazon, one that comes from Microsoft, and the other that comes from a Chinese company. So, and we tested on both original images as well as on blurry images. And like we tried to see like how the 3 platforms perform in terms of the detection of the gender. So if you ask the platform to like identify the gender given this particular image, the original as well as the blur, what is the prediction that each of these systems make? And any idea like what would be the typical predictions? So any guesses? Where do you think things would be more better? Okay, let me break the suspense. So what we observe is that both for original and the blurry images, the face of the white male has been correctly identified like as being a male, whereas for the black female on the right hand side, most of the predictions are incorrect uh, in the original setting, as well as, I mean, in the original setting, at least in one case it is incorrect, and in the bloody setting it is incorrect in two of the three cases. So these has strong repercussions, as we will see. So we will do one like case study in the very beginning of the course, where I'll try to motivate like how these kind of issues in or biases in gender detection and age detection softwares could be could have strong ramifications, because many of these are presently being used for surveillance and criminality detection and tracking and etc. Okay, so of course, nowadays, you are having autonomous hospitals where like patients interact directly with robots rather than any human in the loop. But then, like the question is, are these non-human caregivers like equally trained as the human caregivers? And what happens again if there is an inevitable fatal situation? So as I tried to motivate you in some of the previous slides, so it's still unknown. So in fact, this is true in education also. Suppose you have an completely automated system which allows a person to take up a course, and there is a robot teacher which tries to teach the course one after the other. Now, of course, the robot can evaluate the student at every step, but then, like, who knows how well the evaluation is, how good the evaluation is, how good are the judgments of the robot, and whatever it is suggesting as the next line of say topics for the student, whether it is the right line of topics or not. So same is the case with economy. So there is a lot of buzzword around stock market prediction and things like that using AI algorithms, but then there are also evils associated with it. Like there could be vicious motives that could be engineered into the decision making algorithms to completely jeopardize the stocks. So yeah, so and then there is also this problem that the human in the loop is being continuously cut due to the advent of AI. And these are some of the professions that you see here, which are being eroded, almost eroded by the prevalence of AI. Now, therefore, there is a lot of reskilling required among the humans in case you want to survive in this kind of an autonomous world. So there are like lot of AI safety problems, but then there are some which are very concrete. Like one thing that we are very certain about is like how can you make your agents work safely so that they do not bring harm or avoid harm to the largest extent possible. So then also the question of robustness, like For instance, if there is a change in the like in the environment, in the demography, where you are using a decision making software, then like the predictions should not change drastically. For instance, as I was showing you that example of the white male versus the dark female. So basically across the ethnicity, the result should not be like so varying. So these kind of things should be ensured. And then like we should have this thing inbuilt in our AI system, that it could not be gamed easily. So and the point here is that like as it becomes like as data becomes like one of the gold mines for all these decision making algorithms. So anybody who has access to data is actually like kind of has an overpowering effect. And therefore like the algorithm should be such that this kind of overpowering effects should not be able to render a lot of evil into the decision making that goes on. Okay, so these are some of the things that people are recently interested under AI safety, which is also part of ethical AI. And if time permits, we will talk a little bit about this toward the end of our course. So and therefore like I guess I have more or less motivated you to some extent about the necessity of this course in general. And we will see like with the in the next few lectures we will do two very interesting and very impactful case studies, which will further motivate us as to why this kind of a research, or why this kind of a like thought process that ethics should be inbuilt into AI systems is so important. Okay, so we'll stop here, and I'll see you back tomorrow. Thank you very much.